Today's lesson is on rate of change, and rate of change is a rate that describes on average how much one quantity, x, changes with respect to a change in another quantity, which we call y. In math, the rate of change is represented by the letter m. It also means something else that we're going to find out, which is slope. So the other things listed here, rate of change is also our change in y over change in x. So if we look at the charts that are at the bottom here, in time walking versus the distance walked, as time increased, the distance then increased. So if we look at our x values, they're going up at a rate of 1 each time, and our y values are going up at a rate of 4. So our rate of change is always your change in y over your change in x. So we represent that as a fraction, and we write that as 4 over 1. So it's basically 4 feet for every 1 step. Okay. Our second chart, floor tiles in comparison to areas. We look at the x change. We're going up 3, up 3. Our y values are increasing by 48 each time. So our rate of change, our change in y over change in x would be 48 over 3. So it's 48 inches squared for every 3 tiles. Well, we could also simplify that down because each of those divides by 3. So we get for every 16 inches squared, it occupies 1 tile. So our rate of change is actually 16 over 1, or you can also look at it as 48 over 3. This third chart increases at our x rate is +2 each time. But if you look at the temperature, we're actually going down. So we're going to -8. In this case, the temperature is dropping 8 degrees Fahrenheit. So we have -8 over 2, which in this case is -8 degrees for every 2 hours, which also equates to -4 degrees for every 1 hour. So that's our rate of change. All right, so we're going to look at slope as the ratio of the change of the y coordinate to change in x coordinate, which is basically what we were just looking at. Now we graphed a lot of things in section 1. And some of our lines tended to go this direction, which we call a positive slope. So if you see this little person here, and if they start walking up, have to walk up the line to get anywhere when they're coming in the graph from the left, we say that that slope has a positive slope. If our person has to walk in from the graph and then it goes downhill, we say that's going to be a negative slope. If they're walking along, say like a flat sidewalk or flat surface, we say that it has a 0 slope, which is the kind we like to walk on. And our fourth one, if we're walking up to this line and we're like, whoa, we're going to fall down, whether it's a cliff or whatever it is there, and we call that an undefined slope. Now I'm going to try to show you this video, which goes along with what we're talking about. So sit back and enjoy. You'll have to wait a minute. I'll have to skip an ad, I'm sure.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him, and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. He was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On On the way down the mountain, he says, nice, negative, nice, negative. And now after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead. And all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the Adventure of Slow Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra. Undefined!
Okay, so we're done with that video, which I'm sure you're very sad. Okay, so we're going to go back to our notes. So we've learned about the positive, the negative, the zero slope, and undefined as it appears on a graph. So we can actually find our slope or our rate of change just by looking at a graph, by finding the vertical change, by finding the vertical change over, or the change in y over the change in x. And here's how we do this. So if we're looking for slope on this particular graph, we find our vertical change, which is 3. Our horizontal change is 4. So our slope is 3/4. And as I look at this, this is a nice negative graph. So then I attach a negative to my fraction. So my slope is -3/4. So for every 3 steps it goes down, it goes over 4. All right, so let's go to these two graphs. So to find our slope here, I'm going to take the dots. Now I want you to notice, if you ever have to put dots on your graph to be able to find slope, you want your line crossing through those dots. You don't want them crossing through like right here. So these are right on corners of the box. So what we're going to do is create a right triangle out of this so we can find our vertical and horizontal change. So this here has a length of 3 boxes. This here has a length of 4. So our change in y is 3. Our change in x is 4. We also refer to that as the rise over the run. So your rise is your vertical change. The run is your horizontal. And we also notice it's a nice negative. So we're going to throw in a negative with that. The second line, I've already got the dots, so I'm going to go ahead and connect those. So when I count, my rise is 1 box, 1, 2, sorry, my pen quit working. Hold on just a minute. See if I can get this going again without having to stop my video. I don't know if that will do anything or not. Let's try this. So 1, 2. So I'll unhook it, plug it back in, and see if that helps. So hold on just a second. Okay, should be popping back up again. Okay, so our vertical change, we have 1, vertical change 1, 2, 3, 4, 5, 6, 7 boxes. And then across we're going 3. So my vertical change over my horizontal is 7/3. And then I look back at the graph and I realize as I approach the graph, I'm going to be going uphill. So that's a puff, puff, positive. So it's going to stay 7/3. This graph here has a vertical change of 3, horizontal change of 2. So our change in y over change in x is 3 over 2, and it's going puff, puff, positive. Okay, we're going to switch over to this screen. So this graph here, you might notice, is a flat line, flat horizontal line. So this is a 0 slope. This vertical line here, and this one below it, that's that undefined line. Okay, so it has an undefined slope. So really watch for those. Okay, so sometimes our line is not on a graph. Sometimes they'll give you 2 points that would occur on that particular graph. So then we have to use a formula. And our formula to find slope looks like this. It goes y2 minus y1, all of that over x2 minus x1. So we're going to identify those by putting xy here and xy here, because we know those occur in alphabetical order. Since this is my first set of ordered pairs, I'm going to call those y1 and x1, and this is going to be x2, y2. And then I'm just simply going to plug those into my formula to find the slope. So we're going to take 10 minus 2. Our y2 is 10, our y1 is 2. Our x2 is 2 minus negative 4. So be careful with those negatives. 10 minus 2 is 8. 2 minus 4 would be the same thing as 2. 2 minus negative 4 would be the same thing as 2 plus positive 4, which is 6. So we end up with 4/3. Now on these, you don't have to worry about the negative or positive because it will figure that out itself. Let's go ahead and do this one right here. So change in y is 7 minus 7. Our change in x is negative 2 minus 7. So we end up with 0 on the top, negative 9 on the bottom. Anytime you have 0 on the top, that's a 0 slope. If we do this one down here, we have negative 1 minus 4 and negative 5 minus negative 5, which is going to give us a 0 on the bottom and a negative 5 on the top, and 0 on the bottom. That's one of our undefined lines if you graph that, because both of our x values are at negative 5. I'm going to go ahead and